everyone. This problem has been asked in GATE 2015 session 2 and the subject is analog and digital circuits. It is of numerical answer type. It is of 1 mark. GATE 2015 session 2. It is of 1 mark. This problem is from the operational amplifier and the circuit belongs to integrated circuit. The problem says that the operational amplifier shown in the figure is ideal. The input voltage in volt is Vi is equal to 2 sine 2 pi into 2000 T. The amplitude of the output voltage is. If you want to go about the detailed concept behind this integrated circuit and operational amplifier, kindly refer this NPTEL course Analog Electronic Circuit by Professor Santi Pavan, Department of Electrical Engineering, IIT Madras. I have also provided the YouTube link over here. So before we begin to solve the problem, let us see the concept behind the integrated circuit. So we make the circuit diagram of ideal integrated circuit. It will look like this. So this is capacitor C and the voltage across capacitor C is Vc, and this is feedback current If, input voltage Vi, input current Ii, and Ri the input resistor, and here output voltage represented as V naught. This figure is ideal integrated circuit. So if you see this figure, you can say that at higher frequencies, the capacitor will behave like a short circuit, so the output will be zero. And at zero frequency or for DC signal, the capacitor acts like an open circuit due to its reactance 1 divided by omega C, thus blocking any voltage feedback. As a result, very little negative feedback is provided from the output back to the input of the amplifier at low frequencies. Therefore, with just capacitor C in the feedback path at zero frequency, the op-amp is connected like a normal open loop amplifier with very high open loop gain. That means open loop gain of the op-amp is ideally infinite. This gain can cause op-amp to be unstable and possible voltage tail saturation. So what is the possible solution to avoid this undesirable condition? So to avoid undesirable conditions due to high gain, The circuit connects a high value resistance in parallel with a continuously charging and discharging capacitor C. The addition of this feedback resistor R2 across the capacitor C gives the circuit the characteristics of an inverting amplifier with finite closed loop voltage gain given by R2 divided by R1. So what we are doing? So we are connecting a high value resistance in parallel with capacitor. Take it as R1. This VI. Now resistor is connected in parallel with capacitor C R2, and this is V naught. So therefore at very low frequencies for this circuit the op-amp acts like an inverting amplifier, and at a very high frequency the feedback resistor acts like a short circuit since the impedance of the capacitor is 0 and thus producing output is equal to 0. Now let us solve the problem. So this is the given figure. So take take Z1 as 1 kilo ohm, and we are assuming this 0.1 microfarad in parallel with 1 kilo ohm is Z2. So Z1 as 1 kilo ohm, and Z2, how we can write? Z2 we can write 1 kilo ohm in parallel with 1 divided by j omega c. 1 j omega into zero point 0.1 microfarad 10 to the power minus 6, and numerator will be 1 cross 10 to the power 3 plus 1 divided by j omega into zero point 0.1 into 10 to the power minus 6. Now on simplifying this you will get 1 into 10 to the power 3, 1 plus j omega into 10 to the power minus 4. In this problem we are given with omega, and omega is given as 2 pi into 2000 radian per second. Therefore Z2 can be written like this. So if you put omega is equal to this, you will get 1 in plus j into 1.256637. Or you can write it as 1000 divided by 1 plus j 2 pi divided by 5. Now we know the relation for this integrated circuit is V naught is equal to minus Z2 divided by Z 1 into Vi. Therefore, put all these values. So first I am putting Z2, so that is 1000 divided by 1 plus J 1.25, and Z1 is 1000 into Vi is 2 into sine 2 pi into 2000 t. So V naught equal to minus of 2 sine 2 pi into 2000 t, and 1 plus j 1.25 is written as 1.6 at the angle of 51.488 degree. So if you write in the, then it will become minus of 1.25 sine of 2 pi into 2000 t minus 51.48 degree. This is the final expression for output voltage, and in this problem it is asked that amplitude of the output voltage, amplitude of the output voltage will be 1.25 volt. So this is the answer. So the correct answer for this problem is 1.25, and the range given for this problem is given by the gate examiners is 1.1 to 1.4. That's all. Thank you.